Hello, we are Team 4 from Iowa State's IMSE department, and today we'll be presenting our capstone project we completed for our client Danfoss, a corporation that manufactures parts for hydraulics and heavy machinery.
This is the current layout of the PCP-116 cell that produces PCP units which acts as the brain of hydraulic pumps and motors. Currently, there are 5 operators in this assembly line during a standard process. The demand of this unit is decreasing, and our goal is to propose a new layout that efficiently adjusts with the decreasing demand. The new layout will implement new equipment that will be replacing stations which include the old final test stand, tweak, and single silicon filling machine. The new equipment includes the 2 final test stand and dual silicon filling machine. The work area for Operator 1 is shaded as red. Operator 1 is responsible for 3 stations. The work area for Operator 2 is shaded as blue. The Operator 2 is responsible for 3 stations as well. The travel path and work area for Operator 3 is shaded as green. The travel path accounts for batch flow process. The travel path and work area for Operator 4 is shaded as gray. The travel path is a batch flow process, and the Operator 4 is responsible for 4 stations, one of which is the silicon filling machine identified as one of the bottleneck and to be replaced. The travel path and work area of Operator 5 is shaded as yellow. The final test stand will be replaced with 2 additional test stands. The travel path is a batch flow process. So our objective is to create a new layout design that implement these new equipment and increase the productivity by 5%. From this new layout, we will create a potential staffing plan that adjusts with the decreasing demand level in the next 3 years. The demand level for the following 3 years are listed below. It is projected to decrease by 5,000 units each year.
During our current state analysis, we created a spaghetti diagram, which allowed us to understand the movement of operators in the system and how these operators shared their work. Using this data, we created a relationship diagram, which showed us what stations needed to be near each other and which could be separated, and this helped us generate new layouts for the system. We also ran several time studies of each of the stations in the system, which gave us data we needed to generate an accurate simio model, to compare new layouts, and create an accurate staffing plan. Using the relationship diagram, we designed a future state layout and compared it with the current state layout and the experimental layout designed by our clients, using a weighted decision matrix. Our future state layout scored the highest on this matrix, with a score of 45.3. Our new layout reduces the total travel distance by 27% per shift. It also removes unnecessary batching processes, such as those between the silicone filling station and the final test stand. Finally, this layout would also allow for greater ease of work sharing between operators by having wide walkways for increased mobility and placing stations in sequential order.
This is a comparison of the current layout and the new layout. We mainly focus on worker 3, 4, and 5 when we create a new layout because they are the workers that have the longest travel distance. By reducing time transportation, which is non-value added but necessary time, we manage to increase value added time, which helps us achieve the second objective, increase productivity by 5%. We create two similar models that represent the current state and the future state, and both models are approved by Danfoss. By comparing the output between the two models, we can see that productivity increased by 6%, which achieves our second objective. And by using the new model, we compare different staffing plans, include 5 workers, which is also the current state, versus 4 workers plan and 3 workers plan. The results show that by using 4 workers plan, the assembly line will be able to meet the demand of year 2020 and year 2021. And using 3 workers plan, the assembly line will meet the level of demand for year 2022, which achieves our third objective. By implementing the new layouts and the new staffing plans, the return on investment within 3 years would be around $188,000 with an IRR of 44%. Thank you for watching.